let's proceed. Okay, the second is the law of definite constant proportion. Okay, so what this means is, let's look at the weight of oxygen and hydrogen in one molecule of water. We know that the molecule of water is represented by H2O. H2O has two atoms of hydrogen and one atom of oxygen. So 2 atoms of hydrogen, and I'm going to take unit mass is equal to 1. And so I'll end up having 2 units of hydrogen because there are 2 atoms. And then I have 1 atom of oxygen, and the unit of or unit mass of oxygen, I'll take, the mass of oxygen is 16, almost 2 times the atomic number. Okay. So atomic mass is almost, not every time, this is sometimes, and I will explain this later on. So atomic mass is almost 2 times equal to the atomic number. Okay. So atomic mass is equal to 2 times atomic number. So this is atomic number. It is represented by capital Z or capital Z, however you pronounce it. All right. So mass is 2 times the atomic number. So what is the atomic number of oxygen?
It's 8.
Very good. So the atomic number of oxygen is 8. So its mass is going to be 16. Okay. So if I have 1 atom of oxygen, it's going to have 16 units. So what is the ratio of their weights? The ratio of their weights will be 2 divided by 16, which is equal to, once you simplify that, you end up getting 1:8. Okay. So a pure compound always contains a definitive or constant proportion of elements with regards to mass, irrespective of the method of preparation. So what does that mean? It means irrespective of where or how I created water, the water molecule will always have a weight ratio of 1:8. That means whether I get the water from rain, whether I get the water by evaporating something, or whether I get it by condensing something, irrespective of what my source of water is. Okay.
Even if it has some, even if it's clean water, pure water, right? I mean, if it's dirty or anything, I don't think so.
So even if it's dirty water, it's like, let's say you have water combined with sand. Okay, that I would call that dirty water, right? So if I have that, and if I take out water from that dirty water, it's still going to be H2O. Okay, the water molecules will still float. Okay. All right. Let's proceed.
Wait. Yes. I have a question.
Yeah.
But what if the dirty water contains, let's say, salt? Then it can't only be H2O. There's sodium, hydrogen, and oxygen in it. Because you can't extract, well, you can extract salt from water. It is possible. But if you just take it out and you didn't extract the salt, wouldn't it be sodium, hydrogen, and oxygen?
What she's trying to say is, if you remove it from anywhere, even if it has salt in it, like you said, if you remove it, it will still have 1:8 the weight ratio.
Yeah. No, I understand that. I'm just saying it. If the salt was still left in it, it would be sodium, hydrogen, and oxygen, right?
And chlorine also, Arjun, because salt is
chlorine.
Oh yeah, and chlorine.
Yes, H12O6. So that means hydrogen, chlorine, and oxygen.
Yeah, that's true. That's true. But that is true. But that is, not the topic. It's here. Like this, what she's trying to say here is that even like after removing the salt or any external, dirt that's in the water, even if you remove it, it will still always be 1:8 as well.
Exactly. So that's what I'm saying. But Arjun, to answer your question, if I have salt mixed in the water, then yes, you are right. It will have sodium, it will have chlorine, it will have hydrogen, it will have oxygen, it will have all of these things. But if I remove the salt, if I'm able to extract just the water from that water will have a weight.
Yeah, I get that. We did that in 7th grade. We did an experiment. Yes.
Okay, cool. All right. As long as you're clear, let's proceed. All right, so the law of multiple proportions. Okay, so what does this mean? So let's look at these elements, the combination of elements. First, let's look at hydrogen and oxygen, and then on the other side, let's look at carbon and oxygen. So with hydrogen and oxygen, I can take two elements. So I'm taking one of them as water, which is H2O, and another one as H2O2, which is hydrogen peroxide. So using these two elements, hydrogen and oxygen, we can form these two compounds, water and hydrogen peroxide. And on the other side, I have carbon and oxygen, and using these two elements, I end up getting, or I can form compounds such as carbon monoxide and carbon dioxide. Now, if you look at these two compounds on the left-hand side and on the right-hand side, you'll notice that the first compound, which is water and carbon monoxide, both of them have one oxygen atom, and hydrogen peroxide and carbon dioxide both have two oxygen atoms. Okay, so now let's take the ratio of weights of the elements in each of these compounds. So in each of these compounds, what we're doing is we're taking the ratio of the weights. So if we have the weight of hydrogen over here, since we have two atoms of hydrogen, and the weight of hydrogen atom is 1. So 1 plus 1, because there are two atoms, I'm getting 2. And then we just saw oxygen has an atomic number 8 and its atomic mass is 16, and I have one atom of oxygen, so 16 is the weight. So 2 divided by 16, I end up getting 1:8. Similarly, if I do the same thing for hydrogen peroxide, because I have two hydrogen atoms, I end up getting 2. 2 oxygen atoms, I end up getting 32, because 16 times 2. All right. So when I simplify this, I end up getting 1:16. Now, similarly, let's do the same thing for carbon and oxygen. Okay, carbon monoxide, carbon has an atomic number of 6. Its mass number is going to be 12. Oxygen has an atomic number of 8. So its mass number is going to be 16. So yeah, I'll just take and there is just one atom of each. So 12 divided by 16, 3 by 4, if I simplify it. And then similarly, I take 12, because one atom of carbon and then 2 atoms of oxygen. So that's 16, right? 16, oxygen is 16. So 16 times 2, 32. And when I simplify this, I get 3:8. So now if you look at these numbers, now if I do something with this, there is something that comes out of this. Let me explain what that is. So when we compare both these instances, the ratio of oxygen combining with similar amount of hydrogen in case 1, right, is 8:16. So what I'm going to do is now I'm going to take the ratio of the oxygens. Okay, the ratio of just the oxygens is 8:16, which is 1:2. Even in the right hand side, I'm only going to take the ratio of the oxygens, 4 and 8, right? So in case 2, in the case of carbon, also when I take the ratio of this, I end up getting 1:2. So what is happening here? So the different masses of one of the elements, which combine separately with the fixed mass of other elements, bear a simple ratio when 2 or more elements combine to form more than one compound. Okay? Does that make sense to everybody?
Yeah, it does. Yeah.
Yes, it does.
Okay, good.
Yes, ma'am.
Okay, so if you understood these two things, let us take a look at now just the oxygens. Okay, so what is the oxygen? This, all right. So now let's just take a look at the oxygens. All right. So here what is happening? First I'll take the weight ratio of both the oxygens. So I have 8/16, which is 1/2. And over here I have 4/8. Which is again 1/2. So what it is saying is that the different masses of one of the elements which combine separately, so they combine separately. Once they combine over here with hydrogen and once they combine with carbon, okay, with a fixed mass of other elements. So fixed mass of other elements. So look over here. Over here, carbon is 12. This is a fixed mass. In both these elements, the mass is fixed. Over here also in water and hydrogen peroxide, the mass is fixed. It's 2 hydrogens. Over here, carbon mass is fixed. It's 12. Okay. So with fixed mass of other elements bear a simple ratio when two or more elements combine to form more than one compound. So we have over here we have two elements that are forming more than one compound, right? First is water and then hydrogen peroxide, and both of them are formed using just two elements, hydrogen and oxygen. In the second case, again we have two compounds that are formed by two elements, carbon and oxygen. And as long as hydrogen in the first case is fixed and as long as carbon in the second case is fixed, oxygen is always going to be in the ratio of 1:2. Does that make sense to you?
Ma'am, can you give one more example where oxygen is forming compound?
Okay, let me think about this. Yeah, nitrogen oxide and nitrogen dioxide, right? So let's take nitrogen oxide and nitrogen dioxide. Is nitrogen oxide even a thing? No, it can't be. No. All right, let me think about this. Carbon monoxide and carbon dioxide. Okay, I will, since we are out of time, I will tell you this in the next class because I have to think about this a little because I'm not able to come up with an example right now.
I have
Oxide and sulfur dioxide can,
Sulfur. Hold on. What is the atomic number of sulfur? 16, right? Sulfur oxide and sulfur dioxide can be it. Yes. So can you, Rishit, were you, I think you had the doubt, right? So Rishit, can you do the same ratio with sulfur oxide and sulfur dioxide and tell me in the next class what is the ratio of the masses of oxygen? Can you tell me that? Next class, okay?